Possibly.
That's why I don't trust myself.
Anything.
So we've seen, this is problem set 1 of, we're going to do like a bunch today. So, problem set 1 of 4. We've seen arithmetic series and we've seen geometric series, right?
Yes.
And they were infinite. They could be infinite, correct?
Yes.
So now we're going to look at, I'm going to just give you the formula. If you were to add all the components of an arithmetic series or a geometric series, but instead of doing it so that you could, that you would have to find each individual one, there's a formula where you just stick everything in and you find the sum. Just one single blow, okay? And that formula is this. 4 It always kills me when it's so quiet. Okay. How do you do that?
The chick thing.
Okay. So here is for the arithmetic series. So for example, let's look at example 104.1. Let's see what that means. It says, an arithmetic sequence has a first term of minus 10. So minus 10, right? The first term. And a common difference of 20. Can anybody tell me before I continue the formula for the arithmetic series? A sub n is a sub 1 plus n minus 1d, right?
Yes.
Use the first 4 terms of this sequence. I don't know, that's not the one I want. Well, to write and develop the formula. Okay, so if we're trying to find the sum, how do we find the sum? We've got to find a sub n, right? And the question is, use the first 4 terms. So how do you find the sum of the first 4 terms? You find the 4th term, because that's the one you need, right? Using this, and you've got minus 10 plus 4 minus 1, 20. So a sub n is going to be, what's how much?
60, because it's 4 minus 1.
60, so 50.
Yeah, 50.
So the sum would be, the sum of the first 4 would be 4 divided by 2 times
Negative 10 plus 60.
2 times 40. Okay? It's that simple. Did we understand what I did? It's pretty simple, right? It's pretty straightforward. Now, you can do the same exact thing with the geometric series. Usually, we develop it here in class, but since we're pressed for time, I'm just going to give you the formula, we're going to do an example, and then if you want to know how that formula comes about, feel free to read it in the book, okay? And that formula used in the same exact way, but for a geometric series, is S sub n is 1 minus r to the n. Knowing how it works, do you want an example or you kind of figured it out? Example. Find this, look at example 104.3. Find the sum of the first 10 terms, so n is going to be 10, of the geometric series in the preceding example. And then the preceding example, we have that the first term is minus 8, and the common ratio is minus 2. Now question, what's the formula for geometric series?
A equals A1 Rn minus 1.
That's it? Fine. So we need to find the 10th. So A sub 10 is going to be minus 8 R to the 10 minus 1, right? So if I stick it in here, I've got minus 8, and how much is this?
We have 10 times negative 2.
We don't need it here.
29.
We don't need it. We don't need it. We don't even need to find this. We don't even need to find it. Look, we've got minus 8, 1 minus 2
Minus 2 raised by 10.
to the 10
First.
divided by 1 minus 2. Even easier than the other one. See? So it's just mere simple substitution. Okay? So let's continue to 108, which I said I'm not going to do. Oh, you wanted matrices, right? That's why we no.
Miss,
If we have time again.
the negative 2 is to the 9.
Huh?
The negative 2 is to the 9.
No, it's to 10
It's to the 9.
It's to the 10, look.
Then why is it here to the 9?
Because you're doing the wrong one here. Okay. And then we have 112.